What do a car suspension system, a room heater, and a drone in midair all have in common? They're all control systems. But here's the real question: how do we mathematically model them? Well, let's find out in the next 10 minutes.
In a guided missile system, missile is a mechanical device, launcher is a mechanical device, target is a mechanical device. But all those things are controlled and executed in a computer system. So, how it is done? In a robotic system where robot is designed to perform a specific task, robot is a mechanical device and the specific task is a mechanical action, but all those things are controlled executed in a controller which might not be mechanical system. So how it is done? In any electrical system or mechanical system or any subsystems, all these systems has to be converted into mathematical model, and then the design and control part has to be taken care. So that is why the mathematical model of all these systems is very important. And in this session today we are discussing about that part. The technique is called system modeling. Hello all, welcome to our YouTube channel. Today we will be continuing our control system series with system modeling of all the physical and electrical systems. In our universe, fundamentally there are only three systems: mechanical, electrical, and thermal. Rest of the systems are derived out of these three basic fundamental systems. There might be more systems, but all of them are derived from these three fundamental subsystems. As a control system engineer, the objective is to understand the system and then derive a mathematical relation between input and output, based on which a control system strategy is obtained and a control system is designed. Coming to mechanical system, input will be in terms of force or torque. Output will be in terms of speed, displacement, rotation, angle. These are the states which can have in terms of output. And all these mechanical systems will have force or torque as is input, and output would be in terms of speed or displacement or rotation angle. And coming to electrical system, input will be always voltage or current, and output will be voltage or current. This is the behavior of electrical systems. Coming to thermal system, input would be in terms of pressure and volume. Output will be in terms of temperature. So these are the fundamental system inputs, outputs. Now, when you go deeply into their system, for mechanical systems, any mechanical systems will be made up of only three major components, that is mass, spring, damper. So if you consider x as an displacement, and that is the output. So for mass it will be force is equal to m into a, which is m into d square x by dt square. So this is the relation between input and output for mass. Coming to spring, the force equation for spring is F is equal to minus kx, where k is spring constant. So this is the input and output relation. And if you talk about damper, also called as friction device, for a damper or a friction device, force equation is given by a simple equation: F is equal to minus d into dx by dt, where this d is a damping factor. So if you write overall equation, force equation, force is equal to m into d square x by dt square plus minus kx plus minus d into dx by dt. So this is the input and output relation between mechanical system. This I have written for linear system. Same way for rotational system also can be derived. Only thing is, in rotational system, F equivalent will be torque and mass equivalent will be inertia. Displacement relation will be theta, angular displacement. So this way, for rotational system also, input to output relation can be obtained. So that's about mechanical system. Coming to electrical system, it's very simple. Any electrical system will have only three fundamental components, that is resistor, capacitor, inductor. So if you want to write a relation bit for a resistor, what is the input and output voltage and current relation? It will be V is equal to I into R. Same way for capacitor will be Vc is equal to 1 by C integral of IC dt, where Vc is the capacitor voltage and IC is the capacitor current. And same way if you are trying to write for a inductor, VL is equal to L di by dt. So these are the input and output relation for electrical system. As a control system design engineer, objective is to find out the system from the problem statement, system identification, and then from the system identification, how the system can be represented as a block diagram that has to be done. The block can be replaced with its fundamental component for that system has to be made, and then a single line diagram or circuit diagram has to be made. Based on the circuit diagram or a single diagram, the input and output relation has to be made in terms of mathematical equation. So mathematical representation of that system has to be made. Later, based on the objective of the problem statement, a control system design has to be made. So this is the first step of system modeling. Later we'll be discussing on the mathematical representation of each system, and then how any problem statement can be derived in terms of these particular subsystems. So if you have liked this video, please like, share and subscribe. Thanks for watching.